Good day everyone. We'll start with CDMA Introduction. CDMA is a transmission technique to pass information from mobile station to the base station and from the base station to the mobile station. What is CDMA basically? CDMA is a proprietary standard designed by Qualcomm in the United Nations, which has been the dominant network standard for North America and other parts of Asia. CDMA stands for Code Division Multiple Access. It is a fully digital wireless data transmission system. CDMA uses special random numbers to encode bits of information. Users have control of wide range channel and the bandwidth is in between 1.5 to 5 MHz. It has got an amazing ability to separate noise from the actual data, which is what is astounding. CDMA is an access method. IS-95 was the first OS to use CDMA. 3G systems uses CDMA technology. We'll now see the history. In July 1985, 7 industry veterans decided to build quality communications and outlined a project that has evolved into one of the telecom industry's greatest startup success stories, Qualcomm Incorporated. Introduced in 1988, Omnitrax has grown up into the largest satellite-based commercial mobile system for the transportation industry today. In 1989, the Telecommunication Industry Association, TIA that is, endorsed a digital technology called Time Division Multiple Access, TDMA. Qualcomm introduced Code Division Multiple Access, a superior technology for wireless and data production that changed the global phase of wireless communications forever.
Working of CDMA. CDMA operates on the same frequency bandwidth as that of GSM, that is 1850 MHz to 1910 MHz for the reverse channel, mobile to base, and 1930 MHz to 1990 MHz for the forward channel, that is base to mobile station. Each channel consists of a bandwidth of 1.25 MHz in the IS-95 system, whereas 3.75 MHz in CDMA 2000 system and a 5 MHz bandwidth in UMTS system. Adjacent cell phone towers use the exact same channels as all other towers. This ensures better frequency reuse and also provides for an easier setup of the network. Now, the working of a CDMA system can be distinguished into 4 stages. First stage, scanning. The phone, on being turned on, first scans on the forward channel for a base station. The selection of this base station is based on the strongest signal from the nearest station. Now, the second stage is the passkey generation. In this stage, the phone sends out an encrypted passkey which the nearest strongest base station accepts and provides access to this network. That is, this whole process can be termed as the registration of the device. The third stage is frequency allocation. This device is now given a 1.25 MHz channel bandwidth for the IS-95 system for operation. It can now make calls and receive messages. The last stage is the idle mode. In this mode, the device listens for pages on the forward channel, that is from the mobile station, to let it know when it has an incoming call or an incoming message so that it can respond accordingly.
Good day everyone. We'll start with CDMA Introduction. CDMA is a transmission technique to pass information from mobile station to the base station and from the base station to the mobile station. What is CDMA basically? CDMA is a proprietary standard designed by Qualcomm in the United Nations, which has been the dominant network standard for North America and other parts of Asia. CDMA stands for Code Division Multiple Access. It is a fully digital wireless data transmission system. CDMA uses special random numbers to encode bits of information. Users have control of wide range channels.
CDMA versus GSM. In this slide, we shall now discuss some of the major points of GSM technology. GSM is basically can also be called as TDMA, Time Division Multiple Access. Currently, it is the most dominant technology in the world. It is widely used all over the globe. The operating frequencies of GSM are 900 MHz, 800 MHz, 850 MHz, and 1900 MHz. GSM allows several callers to share the same channel at different time intervals. This is the basic technology of TDMA, whereas in some cases, the same time interval is shared. Now for CDMA. CDMA uses spread spectrum technology. This technology spreads data out over the entire digitized channel. It generates keys at variable encoding rates. That is, CDMA generates distinct sequence codes for every device for security purposes. CDMA technology is highly efficient. It leads to increased frequency reuse, improved battery life, reduced rate of dropped calls, as well as much higher security than GSM. CDMA is widely used in developed nations like USA, Canada, North and as well as South Korea.
Let's take up a CDMA analogy. It's important to understand this from a point of view of understanding the working of CDMA. So say there are 10 people in the same room and five people speak English, 2 speak Spanish and so on, as you can see on your screen. So what we can conclude from this is that an English-speaking man will understand only English, or another man who speaks English, and he may not understand Spanish, Chinese, or Russian, and it's completely redundant to him. So this is really important to understand the further working of CDMA. Let's talk about spread spectrum technology. So whenever we talk about CDMA, it always comes up as it works on spread spectrum technology. So what is it? Well, most of the modulation techniques make sure that the signal bandwidth is reduced. It's for efficiency, of course. But spread spectrum ensures that the signal bandwidth is greater than the minimum required bandwidth for the signal. It sounds bizarre, but it has a concrete reason for it. We'll come to that later. So let's understand why spread spectrum was developed. It offered high security. One of the reasons why is that it is immune to jamming. A jamming signal always uses its energy to lay over the entire bandwidth, and it jams the entire signal, the bandwidth rather. But in case of spread spectrum, the bandwidth is extremely large. So the jamming signal may not have, or in most cases it doesn't have enough energy to cover the whole spectrum. And thus it cannot jam the entire bandwidth. So this is one important reason why it was selected. Another reason is that CDMA working on spread spectrum uses codes. Rather, the whole conversation is coded. So the receiver needs to have prior knowledge about these codes. Now, let's move to the bandwidth of CDMA. It works on 1.25 megahertz of bandwidth. Out of this, it has 0.2 megahertz of guard band. So it's actually 1.23 megahertz. But we're not going to go into the details because we have to keep it simple. Now, all the users in CDMA will transmit their information on one frequency. So you could take a radio station analogy. You could imagine, say, 100 radio stations transmitting their data all on one particular frequency. This is exactly how CDMA works. But there is a technique where you can distinguish between different callers or rather different radio stations in our analogy. The use of unique digital codes. In CDMA, every mobile phone has a unique digital code given to it. You could rather say that every mobile phone speaks a completely different language. So let's get back to the language analogy. Imagine that the base station speaks every language that ever exists. So whenever a mobile phone communicates with the base station will reply back to it. This happens only when the mobile phone is registered with the base station. If it is not, the base station will be completely oblivious to the conversation and will not understand the mobile phone's language and will not reply back. Encoding. Each bit of conversation is encoded with a special code. So let's look at the code generation. Base station and mobile phone have an algorithm known as Walsh code generation to do so. In Walsh codes, it generates random codes which are orthogonal to each other. The speciality of orthogonality is that no two signals which are orthogonal or no two codes which are orthogonal will interfere with each other. So you can now imagine transmitting 100 different radio signals on the same frequency which are orthogonal to each other, and therefore they'll never interfere with each other. Once the Walsh codes are generated, they're convoluted with the data. In these Walsh code include a timestamp A timestamp makes sure that the mobile phone and the base station are in complete sync or are synchronized with each other. It also includes error codes. You can imagine while transmission of data, there are several distortions and an error occurs in the transmitted data. The receiver can thus check the error code and correct the error. Once the encoded code is added to the 1 bit of data, it results into 128 bits of entire data. So now you can imagine 1 bit of data plus 127 bit of encoded data. That's exactly 128 bits of data. Now you can imagine the original 9600 bits per second of conversation has been multiplied to 1.23 megabits per second. This slide gives you the exact outlook of the encoded data. As you can see, actually there's only 1 bit of data plus 127 bits of encoded data. That's exactly 128 bits of CDMA generated signal.